When I tell people I'm a research scientist at the University of Texas Institute for Geophysics, the most common question I get is, you mean you work at a university and you don't teach? Well, what do you do? I tell them all universities teach students. In fact, our university is good at teaching. But to be a world-class university, you also have to have people, scientists and students, that are focusing on how the planet works and on the most important problems that the world faces. In the earth sciences, these are things like climate change, rising sea level, finding secure sources of energy, and natural hazards like volcanoes, earthquakes, tsunamis, and hurricanes. I tell them it's like baseball. You've got your minor leagues and your big leagues. If a university wants to be in the big leagues of earth science, they've got to have people working on problems like this. What we do at the Institute for Geophysics is tackle these kinds of problems. And that's why I've worked here my whole career. These research problems aren't simple. Take climate change, for example. Our main job isn't to argue about whether climate change happens. What we do is collect data from all over the world. One of my colleagues collects samples from corals in the tropics. Another colleague measures isotopes in these corals to track temperature over the past several centuries. But the most visible changes are happening at the poles. In the Arctic Ocean, there's less ice now than at any time in history. For an Arctic project recently, we had to use an icebreaker and helicopters to move equipment around. In the Antarctic, we fly planes with GPS, magnetometers, and ice-penetrating radar. They measure what's happening in the ice and under the ice, how the ice is moving. We have people modeling all this, filling in the gaps in the data we collect, including what's going to happen in the future. At the Institute for Geophysics, lots of research projects relate to hazards. For the last 30 years, we've had a big program with ocean bottom seismographs. 3/4 of the planet is underwater. So if you want to measure earthquakes or if you want to measure earth structure under the oceans, you put seismographs in glass spheres, put them on the bottom, and measure down there. We're one of the few programs in the world that do that. After Hurricanes Katrina and Rita hit the Gulf Coast in 2005, we had a student cruise that went out and measured how the storms had changed the seafloor. Another scientist is measuring how the Mississippi River transports sediments and various nutrients and how the storms affect this. In 2006, there was an earthquake that caused a tsunami in the Solomon Islands. We had a scientist there within 3 weeks, working with the local scientists, figuring out how the coastlines had uplifted, figuring out what had happened to cause the tsunami. In Japan, there were some huge, horrible earthquakes in the 1940s. We have a big project with the Japanese to look at the structure and dynamics of the plate boundary where this happened. On ships, we collected terabytes of seismic data to study this boundary. This involves a lot of people, a lot of processing. This is big science, international science. By studying hazards in the past, we hope to make better predictions about future hazards. Sometimes we go even further back in time to study prehistoric hazards. There's this huge boulder in Tonga, an island in the Pacific. This rock is sitting in the middle of nowhere, about 100 meters, or the length of a football field from the shoreline. I mean, what's with that? How did it get there? We went down there and measured it, took some samples, looked at other evidence. We now think it was thrown up by a massive tsunami, probably within the last few thousand years. We suspect the tsunami was caused by a volcano about 30 kilometers or about 20 miles away. So what is the Institute for Geophysics? We do research all over the world and publish the results. Our main job at the university isn't teaching classes. Our students are our collaborators. They work right alongside us, and they publish too. That's how they learn. The students we work with go with us all over the world. Most universities can't offer this. It's a really diverse program. Last year, we published papers about Alaska, Louisiana, New Jersey, and Texas. We published about Antarctica, Argentina, Canada, the Caribbean, Central America, Greenland, and Japan. We even published papers about the Moon and about Mars. We're Texas. We're the Institute for Geophysics. This is the big leagues of Earth science.